The maximum would be ideally the entire names array, right? So, I mean, it cannot be longer than that.
Right. Yeah.
So if that's the case, then can we do it in like a recursive fashion where, it's a max of 1 to n minus 1 and 2 to n kind of a thing where you basically divide this into left half and right half, and you keep on removing one element from left and one element from right, and kind of.
Are you suggesting a divide and conquer approach?
Yes, very conquer, exactly.
Okay, so you find the max. So you find the result. You divide into two halves. You find the maximum sum subarray that sum up to k in the left. Then you do the same in the right half.
Yes.
Then what do you do?
So if you exceed the sum, basically you just drop that half, and the potential idea is basically the moment you find the sum, you say which array is the longest.
Well, okay. So in example 1, you will divide this into two halves. Let's say the first half is 1 minus 1, 5. The second half is minus 2, 3.
No,
so
the way you divide basically is you take all the elements except for the right element, that's your left half, and you take all the elements and you ignore the 0th element, that's your right.
Okay, so this is not divide and conquer then. So you find the answer in 1 minus 1, 5 minus 2.
Mm-hmm.
So
and minus 1, 5 minus 2, 3.
Okay, and then what do you do?
Then if you are basically exceeding the sum, right, you would drill down one more point. So minus 1, 5, 2, 5 minus 2, 3. Sorry, 5 minus 2. That's it.
Okay, so it sounds to me that you want to solve it in DP. Is that right?
Yes. Yeah, it is DP. Yeah.
Okay. So you want to so that's pretty interesting approach. So our goal is to find the max, find the longest, right? So and let's call our function f, right? So you're saying f of this entire array is dependent on f of this or f of, and then you're saying this is the max of these two.
F returns the length basically. From that point on.
Okay, so but what if the entire array can sum up to 3?
Yeah, that's my initial case.
Okay, so I see. So you're saying you first check if the sum of this entire array is equal to 3, is equal to k. If that is equal to k, of course you just return it, right? Now, if it's not equal to k, then you would just do this, return the max of the 2.
Yeah, because see, the sum of all the elements in the names has to exceed the target. I mean, otherwise I don't even go deeper.
Okay. I think this makes sense.
Then shouldn't we do that in the place where you wrote max? We will say that if then 1 minus 1, 5 minus 2 with 0, right? We have to find the longest in this that has a sum of 0 so that we can append the 3 and the sum becomes 3, right? Max
no, I don't think that's Krishna's point. I think Krishna's point is that we want to find 3 in here, in 1 minus 1, 5 minus 2.
But then that will become 6, right? If you translate it to the original problem. If I was to do
why do you need to keep the 3 though?
Because
why is it 6?
No. So tell me if this is like not correct. So, I was going to say that it will be on the line 12, it will be max of 1, 2, 3, 4, 5 possibilities. The first possibility is that we omit the 3 and the sum targeted becomes 0 because it is k minus 3. Now the second possibility will be that we omit the minus 2 and the target becomes 5, and we go on like that. So we find the maximum length for all these possibilities.
I don't think that's Krishna's point. His point is that, okay, your goal is to find 3, right? The sum needs to be 3, right? Either they sum up to 3 in either the entire array sum up to 3, right? Or in which case you would just return the length of the array, or like you have to get rid of something, right? Now, yeah. So I mean, if it's not the entire array, then the subarray either has to be within 1 minus 1, 5 minus 2, or within minus 1, 5 minus 2, 3. It has to be in one of them.
Yeah.
That's Krishna's point. Okay, so this is pretty interesting, but what would the runtime be? So the runtime would be actually exponential without memoization, of course. Like it would be exponential because it's going to be t. t be the total runtime, right, on this array of length n, right? This is going to be, so first of all, you will try to find the entire sum, right? That's O of n, right? You want to compare the sum to k, right? Then you would do this, compare the two, right? Which would be 2t of m minus 1.
Okay. Yep. So there we can take the prefix sum. I might be going longer route, but just thinking out loud. So you take the prefix sum of the entire array. And now that you have indices values, you can still do the alignment.
Yeah, using a prefix sum, you don't need, then this on will be O of 1. Yeah, but I think this approach makes sense, but I think we're overcomplicating this way too much. It's not a very, this can be solved very, very easily, this problem. But yeah, but I like this idea. Okay, can anyone come up with a more straightforward approach?
What about if you have a prefix sum and then the pointer on the right in this, and then you have one pointer on the left, you try to find you move the left pointer, keep moving till you find the target sum.
So you're suggesting like a 2-pointer approach?
Yeah, but on a prefix sum array.
Okay. So let's have a prefix sum array then. So it will be 1, 0,
0, 5,
6. Sorry, 5, then 3, then 6. Okay.
And then I have a pointer at right pointer at 6, right?
Yeah. And left pointer is at 1.
Yeah.
Okay.
And then I keep moving the left pointer. Does it work? Till I get my targets. No, maybe that's not the right approach.
You have to find the farthest.
Yeah, it should be the other way around, right?
Well, so I mean, I don't know. Maybe this can work. So the sum is the difference between the right pointer and the left pointer, right? So that's the sum in the window, right? So I think you should have a 0 here in the prefix sum. Then your left pointer should initially be at 0, and your right pointer will be at 6. So then maybe the right pointer minus the left pointer currently is equal to 6, right? So that's too big. That's too big. Right, our target is 3, right? So the current difference is 6. Okay, so that's too big. So, but then what do we do, right? We can either move right, we can either decrement the right pointer, or we can increment the left pointer. But both may work. Both may work, right? So at that point, we don't know which one we should go with. All right, that's not how we usually apply 2 pointers. Usually, when we apply 2 pointers, it should be very obvious which pointer we should.
Okay.
Right? Yeah. If it's too big, we increment the left pointer, or if it's too small, then yes. Yeah, so it should be very obvious. Here, it's not obvious. Then I don't think it makes sense. Okay, but I do like this prefix sum array though. So, okay, so when you look at this 5, if you somehow you're at this 5 on line 12, you're at 5. So you know that the prefix sum is 5, but your target is 3. So what does that mean? That means that if there were 2 here, then the sum in this range from 2 to 5, the subarray here would have a sum of 3. Right now, okay, unfortunately, we have a 1 here. So when we have a 3 here, our target is 3. So it would be nice if somewhere to the left of 3 there's a 0. Then their difference would be a 3.
We can do that. We can put these into a dictionary and do that target approach.
Okay, I like that. Okay, I like this idea. So you're saying basically we, instead of putting the prefix sum into an array, we actually don't care about that array. We want to store them in a dictionary, right? So okay, so let's see how that dictionary works. So initially the prefix sum is 1, and the corresponding index is 0, right? Then the prefix sum becomes 0, and the index becomes 1, right? Then the prefix sum becomes 5, and the index becomes 2. Okay, so as we're populating this dictionary, we can check if there's any subarray that sum up to k in the meantime, right? So for example, when you're here on line 16, you know that the current prefix sum is 5, right? But the target is 3. So you're actually looking for a 2 in the dictionary, but there's no 2 in the dictionary. So you continue, right? So the next prefix sum should be 3, and its corresponding index is 3. So okay, so at this point though, right, your prefix sum is 3 and the target is 3. So what number are you looking for in the dictionary? The number you're looking for in the dictionary is a 0, right? But there is a 0 here on line 15. Okay, so what this 0 means is that, okay, the sum up to index 1 is 0. So if we know the sum up to index 1 is 0 and the sum up to index 3 is 3, then we know for sure that the sum from 2 to 3 is 3. Right? But is this the longest? We know this is not the longest because the longest should be this one. So what's wrong? We managed to find a way, we managed to find a subarray that's sum 2 to 3, but it's not the longest. So how can we find the longest?
We should just make note of this and move on, and we'll run a max over whatever we get.
But how can we ever get this 4? I mean, we are already at -2. Like this is the place where we should get a 4. Right. So why did we miss 4? Why did we get 2 instead?
So can we like initialize our map to maybe the sum at
like initial? There's an initial prefix sum, right?
Yes.
Yeah, good. That's the problem. So the initial prefix sum is 0, and we can say its index is at -1, right? Okay, so if we do that, then okay, when you're on line 17, the current sum is 3, so you're looking for a 0, and you do see a 0, and its corresponding index is -1. So when you do 3 minus -1, you get 4. Right. So so this is the place where people sometimes miss. It's when we initialize, we want to initialize 0 minus 1. Right. So well, this problem asks us to find the maximum subarray, the longest subarray, right? So that's why if it's the longest subarray for every index, which one do we want to store? We want to store the leftmost index, right? Because there are actually 2 places where the prefix sum is 0, right? One is at -1, the other one is at 1, right? In these both locations, the prefix sum is 0. But which one do we want? We want the leftmost one, right? Because when we find the length, we are doing 3 minus -1 or 3 minus 1. Of course, we want this one to be as small as possible, right? So that's why when we're populating this dictionary, the value should be as small as possible. Now, if this problem asked us to find the minimum length, then what do? We actually, in that case, we will want to find this value should be as big as possible, right? If the problem asks to find the minimum length, then we want 3 minus 1. Then our dictionary would have a 1 here instead of -1. Does that make sense? Okay, does someone want to implement this one for us?
Let's try with some numbers.
Okay. That's okay. You can just use just execute on Leetcode.
Okay. Just let me look for a quick syntactic error because that's where I usually fail. Okay, ps dot add 0 minus 1. Okay, so it's okay. Sum is equal to 0, max equals to 0, y is equal to 0 less than length I plus in sum I added to sum now. If sum is continuously going up. If ps doesn't contain, then I add sum is the key, the index is the value. So here also sum is the key, index minus 1. Okay, so else if and what if neither of these is true? If contains else, okay, so it does not contain the sum, and it doesn't know. So I added this. Suppose it contains the sum already, and the sum. What happens if neither of these is true? If it falls through this, so it does not contain the sum, the new one. It contains the new ones, and sum minus k it doesn't contain, but it contains the new one. If it contains the new one, then we still want to keep the leftmost value as we discussed, because we are doing maximum. Yeah, we can. Okay, so yeah, nothing. Okay, mat.max. Okay.
Okay.
Oh no, does not contain. Oh, contains key. That is the kind of thing I wanted to catch. Again, contains key. Contains is an hash set. Yeah, contains.
Yeah.
Contains key. No, what will be a problem? So 0, you're expecting 4. Max is equal to max of ps minus sum minus ps sum minus k. Else. Okay, so 4. So did he? And if not contains key sum, so initially we would have come with, we came with 0, so it couldn't have adds.
So on line 15, you are doing, shouldn't you do just I minus
I
ps
minus,
of
yeah.
sum minus k? I mean, it's always the current index minus the previous index.
So oh yeah, I should definitely figure somewhere. Yeah, it's definitely a mistake if I didn't figure anyway. So if we do not have that, then we are doing max of ps sum. PS sum is an index, right?
Yeah, but shouldn't PS sum just shouldn't that just be I? I is the current index.
Yeah. Oh yeah. Okay. Yeah. I and PS sum k is that other one.
Mm-hmm.
Okay. We may not have. Yeah. So but.
Okay, so
minus k.
On line 14, this is not else. I mean, these two conditions are not mutually exclusive. One is you're checking if PS contains sum, the other one you're checking sum minus k. So these are, it doesn't need to be else if, it can just be if. Okay, now let's try it. Okay, good.
Yeah, that's okay.
Oh, it doesn't work for this one. Okay.
Submit.
Okay, submit. Okay, good.